In this video, we will look at Boolean operators. We'll motivate why they are useful by looking at this example that compares if 2 points are equal. In order for 2 points to be the same, they must have the exact same value for both the x-coordinate and the y-coordinate. With what we know so far, we would need to write code like this. We first check if the x-coordinates of the 2 points are the same. If they are, we then need to check if the y-coordinates are the same. As you can see from this code, we need to write the statements we want to do when the points are different in 2 places. We'll see how we can use Boolean operators so we only need to write the code once. We are familiar with the common operators for numeric types, but there are also Boolean operators for Boolean types. We will look at the 3 most common Boolean operators. The AND operator takes 2 operands and produces a new Boolean value, just as the plus operator takes 2 numbers and produces a new number. The OR operator also takes 2 operands and produces a new Boolean value. The NOT operator takes 1 operand and produces a new Boolean value. The negative operator is a mathematical operator that takes 1 operand and produces a new number. For example, if x is negative 3, then negative x is 3. We call operators that take 2 operands binary operators. Operators that take 1 operand are known as unary operators. In the case of the minus sign, there is both a binary version for subtraction and a unary version for negation. There are an infinite number of integers, so we cannot list every possible outcome. But in the case of Boolean values, there are only 2 possible values, so we can write out every answer for every possible set of operands. Since there are 2 values, true and false, and the AND operator takes 2 operands, there are 4 possible cases. The table here shows these results. The variables p and q represent the 2 operands, and we see the 4 cases are: they are both true, p is true and q is false, p is false and q is true, and they are both false. For the AND result to be true, both operands must be true. In all other cases, the result is false. You can remember this by thinking of AND, meaning they are both true. For the same reasons, there are 4 cases for the OR operator. For the results of the OR operator to be true, at least one of the items must be true. So the only time when it is false is when both operands are false. You can remember this by thinking of OR meaning either one of them are true. Since NOT is a unary operator, there are only 2 cases. This is the easiest to remember, as if something is not true, it is false, and if something is not false, it is true. We'll now look at our point equality test again and see how we could solve it using the Boolean operators. For the points to be the same, they must have both the same x-coordinate and the same y-coordinate. The important word I used there is both. Since they both have to be true for the points to be true, we want to use the AND operator. We can write the expression using the AND operator, and now we only need one else statement. We only have to write the code once for the points being the same, and once for the points being different. The Boolean operators do have different precedence levels. In Python, NOT has the highest precedence, AND has the next highest precedence, OR has the lowest precedence. Most people fully parenthesize Boolean expressions rather than relying on the precedence. Without parentheses, this example is difficult to read and determine what it means, but with the parentheses, it is more clear. The comparison operators have a higher precedence than the Boolean operators. This allows us to write our expressions that compare the operands without parentheses, and they perform the operations you want them to. Here's a few more examples of using the various Boolean operators. If we have 2 scores A and B for a game that is played to 15, and you must win by 2, we can use this expression to determine if the game is over. The first case is for A to win. A must have at least 15 points, and at least 2 more points than B. The second case is for B to win. B must have at least 15 points, and at least 2 more points than A. Since the game is over in either case, we use the OR operator. We can also write this a shorter way. The game is over when either player has at least 15 points, and the difference between the scores is at least 2. Note we use OR because only one player must have at least 15 points, but we must use parentheses along with the AND operator to make certain the one player has at least 2 points more than the other. Here is another example with temperatures. I consider the temperature to be pleasant if it is between 60 and 80 degrees Fahrenheit. We need to use the AND operator since I want it to be both greater than 60 and less than 80. Recall that Python has a shorthand for this calculation, but this does not work in most other programming languages. In those languages, you would have to use the AND operator. When using the Boolean operators with multiple if-elif statements, it is easy to think you've handled every situation. This program does not produce any output if the temperature is between 30 and 60 or between 80 and 90. This may be what we want, but you may need to check your conditions carefully to make certain you've done exactly what you want. Here is another point example, but in this case we are first checking if the points are different. Note, for the points to be different, either of the coordinates must be different. Since I used the word either, we want the OR operator. Also note that we used the not equals comparison operator since we are checking if the coordinates are different. The version for checking if the points were the same uses the equals comparison operator along with the AND operator. We could put the not operator in front of that entire expression to check if the points were not equal. Because the not operand has the highest precedence, we must put parentheses around the expression so the not operation is done last. Note the similarity in these equivalent expressions. We negate each comparison and switch the AND and OR operators, and the expressions are equivalent. Just as we have some basic rules of algebra for numbers, such as any number multiplied by 0 is 0, there are some basic rules for Boolean operations. If we use the AND operator in which one of the operands is false, the result is false. This is because both operands must be true for the result of the AND operator to be true. The corresponding Boolean rule for the arithmetic rule that multiplying by 1 produces the same result is that either Boolean value ANDed with true produces the same result. If p is false, false and true is false, which is the value of p. If p is true, true and true is true, which is the value of p in this case. The arithmetic rule that states if you add 0, you do not change the value has the corresponding Boolean algebra rule that if you OR a Boolean value with false, you get the same Boolean value. Again, there are only two cases. If p is true, true or false is true, which is the value of p. If p is false, false or false is false, which is the value of p. Here are two laws known as De Morgan's laws. We've already seen one of these. The second one listed here is the one we used with the points to show the two different equivalent expressions. I remember these by noting that when you negate the entire expression, you negate each operand and switch the AND and OR operators. You may already be convinced the second one is true, but if you wanted to prove it, you could make a truth table showing all the options. Here's a truth table that shows the first De Morgan's law is true. Since there are two Boolean variables, each with two different possible values, there are 4 total cases. We list each case and then check the value of both expressions. Since p or q is true in the first 3 cases and false in the last case, not p or q is the opposite of that. The AND of two values is only true when both values are true, and the only time both not p and not q are true is when both p and q are false. Since we have the same result in all 4 rows for both expressions, we know the expressions are equivalent. There are also distributive laws for Boolean algebra. These are also fairly easy to remember, as they work the same way the arithmetic distributive laws work. If we want to convince ourselves these are true, we would need 8 rows in our truth table since there are 3 Boolean variables, each with 2 choices. You can see this by writing down the 4 cases for 2 operands, and then putting true in front of them, and false in front of a second copy of those same 4 cases. As you write some programs using these Boolean operators, you will become more comfortable with them. Remember that when both expressions need to be true for the result to be considered true, use the AND operator. When only one expression needs to be true for the result to be true, use the OR operator.